This is the jelly enemy for my upcoming N64 game. What you are seeing is being simulated in real time on original N64 hardware. And just for comparison, this is what it looks like with the jiggle turned off. Having that little bit of procedural animation really goes a long way to add life to the enemy. Because it is calculated in real time, it'll respond to any movement experienced by the jelly. So when the jelly lands, it flattens out and jiggles back and forth. When they're pushed by the player, they stretch and wobble. The implementation is actually surprisingly simple too. The physics simulation is just a spring and a point mass. The point mass is being pulled towards a point right above the jelly. Pull force follows the ideal spring equation, which means the strength of the pull is proportional to how far the point is from the target. That pull affects the velocity of the point, which accelerates the point towards the target. When it reaches the target, it still has velocity pulling it in that same direction, so it shoots past the target. After that point is now being pulled back the other way. This repeats back and forth, causing the jelly to jiggle. The jiggle would get out of control if not for some damping I apply each frame by simply scaling the velocity down by a fixed amount. This makes each wiggle smaller than the last until the jelly reaches its rest point. The next step is applying this jiggle motion when rendering. It's actually pretty trivial by taking advantage of the Shear Transform. This type of transform translates points of the mesh in one axis in proportion to how far it is in another axis. It turns out all I need to do to apply this effect is to calculate the vector that points from the base of the jelly to the jiggle point. I then copy that vector into the second column of the model matrix. The model matrix is just a 4x4 grid of numbers that determines how the points of a 3D model are transformed to position it in the world. The X and Z components of this vector go here, and they control how much the model shears. This top value shears left and right, and the bottom one front to back. The Y value in the center causes the jelly to stretch up and down. That scaling up and down actually introduces a problem. See, the volume is not preserved. The shearing, on the other hand, actually does preserve the volume. The final touch to actually preserve volume while the jelly wiggles around is to scale the blob horizontally to compensate for that vertical stretch. And the amount that I stretch in both the X and Z axis is actually 1 over the square root of the vertical scale. I need to apply the square root since I'm scaling in 2 axes horizontally, and those multiply together, and that multiplied with the vertical scale cancels it all out to maintain the same volume. And so doing this makes it so that when the jelly squishes down, it also widens and flattens out. Or if it stretches to be really tall, it gets skinnier. So how much does this cost to run? Well, the spring equations are actually relatively cheap. It only consists of multiplies and adds. An add only takes 3 cycles and a multiply 5. With 12 adds and 6 multiplies, that's about 66 cycles for the floating point math. I expected the rendering to take longer. It has a square root and a divide, which each take a whopping 29 cycles to complete. The total instruction count for the rendering is 11 multiplies, 3 adds, a square root, and a divide, for a total of 122 floating point cycles. Of course, floating point math is not the only work happening here, so in the end I spend about 10.7 microseconds calculating physics and only 10.8 microseconds in the render code. That's a total of 21.5 microseconds per jelly per frame, which is not bad at all for a really cheap approximation of a soft body. When I started on this, I wasn't entirely sure how the jiggle was going to turn out, and I was actually pretty surprised how good it looks. With the jiggle, it really feels grounded in the world and it actually has some life, and the movements don't feel abrupt. This little bit of extra time spent in the jiggle is definitely worth it. If you want to follow the progress of my original N64 game, be sure to subscribe. If you enjoyed this video, be sure to hit the like button. As always, I'd like to thank my Patreon supporters scrolling down the screen here. Your support is greatly appreciated. And until next time, take care. That should do.